Imagine a plane. Now imagine that plane disappearing. Not literally vanishing, but becoming invisible to radar. That's the basic idea behind stealth technology. Radar is like a flashlight for finding planes in the sky. It sends out waves and listens for the echoes that bounce back. Stealth technology is designed to make these echoes as small as possible. This is done by using special shapes that deflect radar waves away, and by using materials that absorb radar waves instead of reflecting them. The result is an aircraft that is much harder to detect on radar, making it a ghost in the sky. Building the first stealth aircraft, the F-117 Nighthawk, was a huge challenge. It was like nothing anyone had ever built before. We had to figure out new ways to design aircraft, new materials to build them with, and new ways to test them. One of the biggest challenges was figuring out how to make an airplane that could fly while still having a shape that deflected radar waves. This required the development of entirely new computer programs to help design the aircraft. We also had to develop new manufacturing techniques because the F-117's shape was so complex. It was a time of incredible innovation and hard work, but in the end, we succeeded in creating an aircraft that was truly revolutionary. Developing stealth technology was not cheap. It required massive investment in research, development, and testing. New materials like radar-absorbent coatings had to be invented and produced. Building the aircraft themselves was also expensive. The F-117, for example, was made up of thousands of small, precisely shaped panels that had to be assembled with extreme accuracy. But the cost was considered necessary. Stealth technology was seen as a game-changer, something that could give a decisive advantage in a conflict. In a world where the threat of nuclear war was very real, that advantage was priceless. The Cold War was a time of great tension between the United States and the Soviet Union. Both sides had thousands of nuclear weapons, and the fear of a devastating war was always present. Stealth technology played a crucial role in this tense environment. Stealth bombers like the B-2 Spirit could penetrate enemy airspace undetected. This capability was a major deterrent to aggression, as it meant that even if one side launched a surprise attack, the other side could still retaliate. The ability to deliver a counterstrike even after a surprise attack is known as second strike capability. Stealth technology made this capability much more credible, and this, in turn, helped to prevent the Cold War from turning hot. Section 5. Stealth today, still relevant in a changing world? The Cold War is over, but stealth technology remains important. In today's world, nations are increasingly relying on sophisticated air defense systems to protect their airspace. These systems are designed to detect and shoot down incoming aircraft. Stealth technology helps overcome these defenses. By making aircraft difficult to detect, stealth gives them a better chance of reaching their targets and carrying out their missions successfully. However, stealth technology is not a magic bullet. It is constantly evolving, and new technologies are being developed to counter it. Maintaining a technological edge in this area remains a key challenge for militaries around the world. Section 6. Not just planes, stealth and other weapons. While we often think of stealth in the context of aircraft, it's not limited to planes. The same principles of deflecting and absorbing radar waves can be applied to other military platforms as well. Ships, for example, can be designed with stealth features to minimize their radar signature. This makes them harder for enemy ships and aircraft to detect. Similarly, missiles can also be designed with stealth features to make them harder to track and intercept. The application of stealth technology goes beyond just radar. Reducing an object's heat signature, noise emissions, and even its visual profile can all contribute to making it more difficult to detect and track. Section 7. Beyond radar. The future of stealth is more than shapes. While the initial focus of stealth technology was on reducing radar reflections, the future of stealth is likely to be much broader. New technologies are being explored that go beyond just shapes and materials. One area of research is in developing active stealth technologies. These systems would use energy to jam or confuse enemy radar, making it even more difficult to detect stealth aircraft. Another area of research is in developing adaptive camouflage. This technology would allow aircraft and other military platforms to change their appearance in real time, blending in with their surroundings and making them virtually invisible. Section 8. The legacy of stealth, how it changed warfare. Stealth technology has had a profound impact on warfare. It has changed the way wars are planned and fought, and it has forced adversaries to develop new tactics and technologies to counter it. One of the most significant impacts of stealth has been to increase the importance of intelligence, surveillance, and reconnaissance. Because stealth aircraft are so difficult to detect, it is essential to have good intelligence on their location and movements in order to counter them. Stealth has also led to the development of new weapons and tactics. Long-range, precision-guided weapons have become increasingly important, as they allow militaries to strike targets from afar without having to penetrate heavily defended airspace. Section 9. Conclusion: Stealth bombers, a legacy of innovation. From the first secret flights of the F-117 to the advanced capabilities of the B-2, stealth bombers represent a remarkable feat of engineering and a testament to human ingenuity. The development and deployment of stealth technology have shaped the landscape of modern warfare, influencing strategy, tactics, and the balance of power on a global scale. While the future of warfare remains uncertain, one thing is clear: the legacy of stealth is one of constant innovation and adaptation.